engine components. They are milled, ground, drilled and bored. All these operations expose fresh steel to the atmosphere, more surfaces vulnerable to corrosion. The nearer these components come to their precision finish, the less can corrosion be tolerated. Cutting fluid both cools and lubricates in order to facilitate the cut, reduce the power needed, and prolong the life of the cutting tool. The fluid must flow rapidly and wet the surface thoroughly. It must be chemically stable, and it must protect the freshly cut surfaces from corrosion. Cutting fluid may be neat oil, as in this case, or it may be an oil and water emulsion. In formulating the complex oil, the research men must ensure that its own constituent elements cause no damage to tools or workpieces. Further, it must be non-toxic and without objectionable smell, so as not to be a danger or discomfort to the machine operators. The more highly machined the surface, the more it must be protected from corrosion, as with these gudgeon pins. Wire brushes remove sharp edges from the polished pins, and oil and water is used to cool the brushes. Water on a polished surface, a breeding ground for rust. If the water is allowed to remain on the pins, they would rapidly become useless. Here is the defense. The liquid in the bath is dewatering and protecting fluid. With the permission of the manufacturers, we removed one of the pins before it was dipped in the bath. Before assembly, the pins are dipped in a bath of trichloroethylene, and the protective film is removed without difficulty. Precision engine parts must be inspected before assembly. The tolerance permitted is plus or minus 1/10,000th of an inch. Anything outside these limits is discarded. Often gudgeon pins have to wait several days before testing and assembly. Let's have a look at the pin which we put on one side. After one day it looks much the same, but magnified 400 times, rust is clearly seen to be forming. After a week, rust has taken a firm hold and is clearly visible to the naked eye. This pin will be scrapped. The gudgeon pins now meet up with a connecting rod and piston. When completed, the assembly is thoroughly sprayed with fresh oil. Its function is to provide lubrication to piston rings and other moving parts when the engine is first started. The cylinder blocks arrive at the beginning of the automated line. Here they are turned into precision finished blocks where tolerances are again measured in 10,000ths of an inch. The line, which cost £1.5 million to install, performs every operation in this complicated process rhythmically and entirely automatically. Each machine is linked to its neighbor, and only when each individual operation is finished is the signal given for the line to advance. A series of complex oil feed systems supply neat mineral oil for cutting, milling, drilling, and cleaning out swarf. An equally complex oil feed system is required to lubricate the machinery. Once again, the oil is serving as coolant, lubricant, and corrosion inhibitor. This time, the oil is removed. What is more, the blocks are washed in hot water, surely an invitation to rust. But the water contains a corrosion inhibitor. When the block dries, this remains to protect the surface of the metal. Sometimes it happens that on its journey from the foundry, a block becomes rusty, and when the block has been machined, a trace of rust remains. At the end of the line, each block is inspected. Every fault has a code number. This block shows a trace of rust. The fault is coded as number 39. Enemy invasion calls for counterattack. enemy 39 can be eliminated in the pickle bath. After immersion in acid, the block will be inspected again, and if no trace of rust remains, it may be allowed to follow others to the engine assembly line. First, the pistons and crankshafts are fitted. Then, more oil to provide initial lubrication when the engine is first started. Now the engine begins to take shape. The engine is now ready to receive its first fill of oil. This will stay with the engine until it has done at least 300 miles on the road. All engines made in this factory are run before being sent to the final assembly line. Until a few minutes ago, this engine was a collection of metal pieces. Now it has a life of its own. Final adjustments are made to the tappets. Oil is already beginning its work of lubrication and protection. The cooling water used temporarily for the test is also laced with a corrosion inhibitor. Assembly lines are vital to the life of the factory. Every line is lubricated and so protected from rust. Slowly, the painted shell picks up its accessories as it moves down the line. Some fittings, such as the windscreen wiper motors, received permanent lubrication and therefore built-in protection from corrosion when first manufactured, and are not expected to need further treatment during their working life. Now comes the moment when the body meets its engine, complete with gearbox and front suspension. A computer ensures that each body is met by the right engine. A few final touches remain. Water is put into the cooling system. Not ordinary water. This water contains antifreeze and also a corrosion inhibitor. Then another completed car is ready to be driven off the line. Nothing extraordinary. It happens every few minutes in this factory.